Okay, so today we are going to build upon what we've been doing, and we're just going to start adding some more complex equations. I don't even know, complex probably isn't even the right word. We're just going to keep adding. We're adding to our bucket of things that we know about equations we can solve. At this point, we should confidently say we can solve our basic one-step equations. Okay, we should also say that we introduced the idea yesterday that we should be able to start talking about and solving equations that have multiple signs in them. So like, I have to sneeze. Okay, I think we're good now. So x plus negative 4 equals 8. What did we say we would do to solve this?
Or no, plus 4, I don't know.
Right, we could think about it as adding 4 or as subtracting negative 4, right? Because here is our variable. The number we want to get rid of is negative 4. Guys, when I write on the dry erase board, like this is stuff you already have in your notes, so you don't need to write this down again. If you want to, please do, but, okay? The operation directly in front of it is addition. All right, how do we undo addition? Subtraction, and subtracting negative 4 is the same thing as adding 4. Right? Some of us decided we knew adding the opposite and we could turn that into one sign. All of that is great as an option too. Okay? Today we're going to have now multiple operations happening, which means we want to combine the things that we've learned with multiplication and division, as well as what we've combined with addition and subtraction. Okay, the key is that whenever we are solving something that has multiple steps in it, we want to do order of operations backwards. So as much as I dislike it, we all agreed, right? Order of operations to us is PEMDAS. So order of operations backwards is going to be SADMEP. I don't know. But if we're going in reverse order, what operation should we be doing first? A subtraction and addition, right? They come together. So we are going to undo addition and subtraction first. And our second step will be to undo any multiplication or division. So we're always going to show our work just like we did yesterday, because as we add more steps, we need to make sure we can follow where we're at. So every single time showing your step, showing an equivalent equation. Right, our objective is that every time we are creating a new equation that is an equivalent equation to what we originally started with. So if we have something like 2y plus 7 equals 15. We should agree that this has two operations happening in it. Right here we see some multiplication, and right here we see some addition. So the first thing that we are going to do, right, step 1 says to undo any addition or subtraction. To create that equivalent equation, right, whatever we do on one side of the equal sign, we have to do the exact same thing on the other side of the equal sign. So how do we undo adding 7? Subtracting 7, right? We should know that because that was what we were practicing yesterday. So if we subtract 7 here, I also need to subtract 7 here. Okay, great, right? This is our inverse operation happening, right? These are canceling out. What do I have left over on the left-hand side?
2y.
2y. What do I have left over on the right-hand side?
8.
Because 15 minus 7 is 8. Okay, today we just have to keep going because we still have an operation left, right? So our variable is y. What operation is holding these two together? Multiplication. How do we undo multiplication? Division. So we are going to divide each side by 2. Right, there's our inverse operation. And we'll get y equals 4. Okay, I have a new question for you today. How can I decide if I'm right? How can I prove to someone that I'm right? Charisma?
2 times 4 plus 7.
And what should that equal when you do 2 times 4 plus 7?
15.
Why would that prove that we're right? Keep going, Charisma.
Because you're just substituting in what you got for y.
I love this word. So we're substituting in what we got for y, and we're showing what?
That's what y equals.
But why does that prove it? This is a little bit of a deeper piece here. Aubrey, what do you think?
Because like they both equal 15 on each side.
And why would that be important?
Because
This says, and I know you're like, but that's a really dumb question, Mrs. McKinney, because they're equal, but that's not always going to be the case as we move forward, right? This symbol right here says that whatever stuff I have over here has to be the exact same value as whatever stuff I have over here. Right? So it's fine that I have 2 $5 bills and Charisma has a $10 bill. We both have the same amount. They look different, but they have to equal the same thing. And that's what this says. Now watch. What if right here we plugged this 4 in? Do we still get that they equal the same thing? Because what we're doing is just rewriting it so it's still the same value. It just looks different. Okay? Let's go a little bit further. Here's one of my students' favorites. Two-thirds W minus 7 equals negative 4/5. Usually one of my students' first response is, I don't do fractions. I'm not going to do that one. Leave it blank. Skip. Next page. Because for some reason we look at fractions and we decide that fractions make a problem hard. But what did we just learn over the last week and a half? Fractions are friends, and how can we deal with fractions if we really don't like them? Use them with your calculator. Do not let the world change because you see a fraction. Where is our variable up here? What is our variable? Maybe that's a better starting question. W. So we're going to focus on this side of the equation over here. Right? We need to get W by itself, so that 7 and that 2/3 need to go away. Which one are we going to make go away first?
Fraction.
Why the 7? I gave you a rule.
because it's addition and subtraction.
And why are we doing addition and subtraction first?
Because we're doing that.
Because we're doing order of operations backwards. So addition and subtraction is what we have to undo first. Okay? So we're going to undo subtracting the 7. How do we undo subtracting 7? Add 7. And how are you going to calculate negative 4/5 plus 7? You're going to pick up a calculator and you're going to put it in your calculator. So we'll get 6 1/5. Does your calculator give you 6 1/5 or does it give you like 31/5? 6 1/5? Okay. Sometimes I do the wrong format when I'm just doing it in my head. Now what do we have? Where's our variable? Right over here. So this is the number we have to move. Guys, always cover, if you're not sure which one to move, always cover the side of the equal sign that the variable's not on. You never want to move the side that has no variable. Okay, so we need to move that 2/3. I want to get some thoughts from the peanut gallery here. How do we want to get rid of that 2/3? How is that that 2/3 attached to that W? Multiplication. How do we undo multiplication? So we could divide by 2/3. Does anybody else have a thought? I think I maybe heard something over here, but I'm not for sure. Has anybody heard to multiply by the reciprocal? Okay, dividing by a fraction is the same thing as multiplying by a reciprocal. So whether you decide to write down on your paper this, if you've never done multiplying by a reciprocal, I wouldn't necessarily start now. If this is what you've seen before, keep doing it. Okay, but division with a fraction is the same thing as multiplying by a reciprocal, right? Remember in like middle school when you were doing 2/3 divided by 4/5 and you all wanted to like strangle your teachers because you hated fractions because you were team decimal, right? And you had to rewrite it like this, right? So they are the same thing, but if you're fine with just dividing by it, that's fine.
At my old school, if you like divided it like what that is, like you got points taken off on like tests.
Well, mathematically that is correct. So we cannot take off points for it here. So what is 6 1/5 divided by 2/3?
9 3/10.
Okay, there. How we doing so far? Thumbs up, thumbs down. Thumbs up, we're saying okay, so far we're following. I don't know why sometimes it's so hard for me to like think of a new letter. I was like, what letter should I use this time? Okay, so yesterday, right, we were talking about that idea of really not wanting to start the habit of flipping which side of the equal sign they're on, or changing it to an X, or making sure that it looks in this picture perfect way that we like it to look, because it realistically won't work when all of a sudden all of those are letters later next week. Yeah, we'll deal with that when we get there. I promise you'll be able to do it just fine. My students always can. Okay, so when we look at this problem, we might not like that the C is over here, but let's just decide, okay, we know that we're doing our order of operations backwards. And so since our variable is over here on this side, we're gonna cover up the left-hand side of our equal sign because we don't want to focus on that side yet. Okay, and we want to undo addition and subtraction first. So what up here is attached with addition and subtraction? The 4. Are we in agreement with that statement? How are we going to move that 4? But this is subtraction, so why am I not going to add it?
Because it's not in front, you're not subtracting something.
Oh, excellent. Right? We don't look at what follows it, right? I've been drawing this arrow in front, in front, in front. This has nothing to do with the 4. We want to look in front of the 4. Is that 4 positive or is that 4 negative? Positive. So if I say that this is a positive 4, what does that positive look a whole lot like? A plus sign, addition. And how do we undo addition? Subtraction. And so we're going to subtract 4 from each side. And what is negative 16 minus 4? Negative 20. Right, use a calculator if you need to, no big deal. Now we have to be careful here because when I cross these off, what do I have left? Negative 2c. Negative 2c. But wait, I thought this was a subtraction. So is that a subtraction or is that a negative? Uh-huh. Right? Mrs. McKinney, is that a subtraction or a negative? Yup. Because it's all based on how we read it. What is this word? read or is it red? It's both. How do we determine which one we want to use? Context. Is this a negative or is this a subtraction? Both. How do we determine which one we're going to use? Context. Right, this one, 4 minus 2c, I read as subtraction. But when that 4 is no longer sitting there, that is a negative 2. How are we going to undo multiplying by a negative 2?
Divide.
Divide by it. If you want to flip this to a c equals 10, that's fine. One more problem, we're done with notes, and we're going to do an activity. Oh, I just didn't see. B minus 5 all over 3 equals 8. What do we want to do first on this one? How many of you think you know but you don't want to say it because you're questioning everything you've learned? This is what starts to happen at this point. What are we questioning in our brain that we've always learned? What do we think we want to do first? Times 3. But then are you going yourself, but wait, Mrs. McKinney told me time to do addition and subtraction first.
But that's when there's addition.
I mean, there's addition and subtraction happening here.
Yeah.
So why am I not adding 5 first? Why have my teachers told me to multiply by 3 first? That's not order of operations backwards.
I don't really know how to answer the question you're asking.
Right, we tend not to. My students rarely do at this point. Why? Because, well, I don't know, I was just told to do it. How many of you say that? I don't know, I was just told to do it. I did it because that's what I was told. Okay, but why? Why? Okay, and this comes back to the exact same reason as to why we typed things in the calculator the way that we did. If we saw this, but we typed it into our calculator just the way we read it, would we get the correct answer?
No.
No. What did we determine was really happening up here with this 2 and 6? What were they sitting inside of?
Parentheses.
So there are really parentheses around here. And where do parentheses fall in order of operations backwards? Last. Okay? That is what gives us permission to multiply by the 3 first. So when we have multiple things happening over a fraction, I don't know that there's a real name for this. I made it up. I called it a large fraction. Ooh, maybe that should be a Teach Mrs. McKinney question. I don't even know if there's an answer to this. Oops, what is the name for a large fraction? I have no idea if there's even an answer to that. Okay, so for a fraction that has multiple things sitting on top of it. Okay, so we're going to multiply by 3 first. This 3 has nothing to do with the b minus 5. Just like we've been talking about, those cancel each other out. Then what are we going to do?